So it'd be probably pretty cool to make sure you pay attention to this one. For this problem, what it's asking us to do is to describe the transformation. Does it ask us to graph?
Yeah.
Okay, great. So when we're first going to describe this transformation, the first thing I'm going to do is I'm just going to kind of rearrange it to make so it's a little bit more familiar for us. So they wrote the constant in front. We always like to write the constant in back. So I'm just going to rearrange it first of all. Negative x plus 5 squared plus 2. Okay? I want to write it into the form that I'm used to. Now, we have reviewed a lot of the transformations. Vertical, shift, up and down. We've talked about horizontal, shift, left and right. And we've also talked about reflections, and we've done some shrinking and some stretching. So when we're looking at a problem like this, first thing let's do is let's kind of determine what each number is doing. So if I look at this 2, all right, and if I remember, maybe I'll have some number here. If I have f of x equals f of x plus c, what that told us from our notes was we were going to have a vertical shift c units. Okay? So what that's telling me is I'm actually going to shift my whole graph up 2 because it's positive. So I'll just write shift up 2. All right? Now let's look at this 5. From our notes, and again, I'll go back through my standard kind of form. Function takes care of 2 points, kind of like our x and our y a little bit, our input or output. When we're adding, see here, I'm adding 2 to my function. I'm adding 2 to the f of x. So since I'm adding to the f of x, I'm adding to my function, I'm going to shift the whole graph up. I'm actually going to shift my y values. Here, I'm adding to my actual x coordinate. So therefore, I know it's going to do something horizontally. So because I'm affecting actually the x value. Over here, I was saying f of x plus c, that vertical shifts it. So next thing I remember, when I had f of x, and I do f of x plus c, all right, what we tried to remember was, remember this is always going to be the opposite. And I've showed and I've talked about why it's the opposite, how it works. But if you guys can just always remember, that's not going to be a shift to the right. That's actually going to be a shift to the left. So it's a horizontal shift. And why is it horizontal? Because your x values is your horizontal axis, right? So since this is affecting our x value, it's actually going to shift it horizontally. So this tells you a horizontal shift c units. Well, what are our units? Well, here we're going to shift 5 units to the left. Alright? Then the last thing we do is we have this negative sign. And last thing we looked at was talking about reflections. So what are going to be your reflections? And we had 2 different reflections. We had f of x equals negative f of x. And then we had f of x equals f of negative x. And I'll try to go through this one more time. If you guys have a coordinate point, okay? And remember, this is the same thing as, x, f of x, because we're dealing with functions. But if you guys think of a coordinate point as x and y, if I make my negative f of x, if I make this point negative, what that does is that's the same thing as making my y coordinate negative. So what that's going to do is, instead of it being positive, so if my coordinate point was 2, 4, my coordinate point was 2, 4. Now my coordinate point is going to be 2, negative 4. So what it did was it reflected about the x-axis. So when I make my f of x negative, that's going to be a reflection about the x-axis. However, if I make my x negative, that's like taking my coordinate point to be negative. So that instead of it being over there, it'd be over here. So that's a negative 2, 4.
Can you explain it the other way, because I can't see it?
So what happens is, what happens is when I make my x negative, it's reflecting it about the y. Now when I look over here, that's really crooked. I'm sorry about that. But when I make my x value negative, because it says f of x equals f of negative x, when I make my x coordinate negative, that's reflecting it about the y-axis. So therefore, we need to look at this. We need to look at this negative sign and say, well, what is this doing? Is this changing the f of x or the y coordinate or output value, or is this changing the x? Well, since it's outside of my parentheses, it's doing this one, which is a reflection about the x-axis. And this is a reflection about the y-axis. Okay, so those are your two reflections.
So you use them to know which way reflecting to.
Correct. All right, so yes, you guys do need to know those. And you're not going to know them by memorizing. You're going to know them by doing your work. So therefore, this tells us to reflect our x-axis. Okay, so now we need to graph it.
Square.
Huh?
What's the square doing?
Yeah, that tells us what our parent graph is going to be. So if we look at this from our previous chapter, here's our original function. It roughly looks something like that. So now what we need to do is just follow what our transformations are. Well, we're going to shift 5 units to the left. 1, 2, 3, 4, 5. We're going to shift up 2. 1, 2, and then we're going to flip it about the x-axis. Right? So really, this point's going to move over here and up here. So if we move it over 5, or up 2, and then it shadows downward. So that's what my graph would look like. Make sense?
Yes.
No? Yes?
Got it.
Ready?
Why is it?
Because I had that -1.
Okay.
Told you to reflect about the x-axis. Whenever you have a negative function, that's how you flip. Make sense? Just remember, if it's negative outside of it, it's x-axis. If it's negative inside, it's going to be the y-axis. Yes? On the video? As long as you go and fill this up first.